Think about, just staring up at the night sky. For, gosh, millennia, those tiny lights have sparked our curiosity, driving this really fundamental human need to understand our place in, the vastness of the cosmos. It's a story as old as our ability to look up, isn't it?
Oh, absolutely. And what a story it is, full of twists, turns, moments that just completely redefine how we see things. Today, we're diving deep into the perspective of one of its most compelling storytellers, Carl Sagan. We're exploring excerpts from his incredible work, Cosmos.
Exactly. Cosmos. It's not just a book. It's really a journey. It sweeps across these unimaginable distances and scales, from the tiniest subatomic particles right up to the grand architecture of galaxies.
Yeah.
And it traces the origins of life, ponders the possibility of other civilizations out there.
Right.
So our mission in this deep dive is to kind of pull out the key insights about how our understanding of the universe is always evolving, the delicate nature of life, and maybe where we're headed, our future, within this cosmic ocean.
And listeners should prepare for some, well, genuinely surprising revelations and those wonderful aha moments that, make learning so addictive.
Totally. Okay, so let's unpack this. What jumped out at you right away reading these excerpts?
Well, what's immediately striking, I think, is the tension Sagan paints so vividly. It's this contrast between humanity's relentless quest for knowledge and the ever-present backdrop of global military activity, especially during that Cold War period when he was filming.
Yeah, it's fascinating how he weaves in his own experiences filming the Cosmos series around the world. He mentions being in Egypt during, practice strafing runs by their Air Force,
Right.
navigating NATO maneuvers and artillery fire in Greece, and even that story about a Czech fighter jet buzzing them just because their walkie-talkies look suspicious. It really grounds this cosmic exploration in, the gritty realities of our world back then.
And you can't overlook the state security agents who were basically shadowing them in several countries, or the difficulties they had trying to film in the USSR, wanting to talk about the Russian space pioneer Tsiolkovsky. But it was all happening against the backdrop of ongoing dissident trials.
It just underscores how much the political climate can affect, everything, even the pure pursuit of universal knowledge.
It really does. It paints this picture of a world grappling with huge earthly concerns and these vast cosmic questions all at the same time. But, despite all those very real geopolitical tensions, the sheer scale of military presence, Sagan emphasizes that science just keeps pushing forward.
Yeah, that relentless march. It's like a testament to our inherent drive to understand, isn't it? A process that, it never really ends. It's always revealing new layers, new complexities about the cosmos.
Precisely. And he sets that stage perfectly by highlighting how our understanding isn't static. It's not just a collection of facts. It's a continuously evolving story. A prime example he gives is the Voyager 1 and 2 missions encountering the Saturn system.
Oh, those flybys. They were
Yeah.
absolute game changers, weren't they?
Totally. Before Voyager, Saturn was, that iconic ringed planet in our telescopes. Beautiful, but a bit distant and enigmatic.
And Voyager just unveiled this incredible level of complexity we never imagined. The intricate details and the rings, how dynamic they were, the sheer variety and, frankly, strangeness of its moons. It just shattered our simpler picture of Saturn.
Absolutely. The key takeaway there is that even things we think we know, familiar objects in our own solar system, can hold these incredible, unexpected complexities. It really shows the limits of just observing from afar.
Right.
And among Saturn's moons, Titan really stands out, just fascinating. We learned it has this substantial atmosphere, remarkably similar in some ways to what we think early Earth's atmosphere was like, thick with organic molecules, forming this dense haze.
Wow.
And there's even strong evidence pointing towards, maybe liquid hydrocarbon oceans on its surface. Imagine seas and rain made of methane instead of water. It's mind-boggling. Thinking of these other worlds with such, radically different chemistries and environments. And this idea keeps cropping up, doesn't it? That planetary systems might be the norm, not the exception. That seems supported by more recent observations, too.
Indeed. The detection of these debris rings around young stars is pretty compelling evidence that planet formation is likely a common process happening all over our galaxy. These rings are thought to be the very stuff coalescing into new planets. It hints at just an abundance of planets out there.
Which naturally leads to another really profound idea. Sagan explores the building blocks of life itself. It's not just planets that might be plentiful.
Right.
The actual stuff life could arise from might also be widespread.
Exactly. And what's truly fascinating there is the discovery of this remarkable array of organic molecules Dozens of different kinds, some surprisingly complex, found within those vast, cold clouds of gas and dust just drifting between the stars.
And these aren't just theories, right? They were actually detected. Detected, yeah. Using radio telescopes, peering deep into these interstellar nurseries. So, if these essential ingredients are out there in such abundance all across the cosmos.
It raises this huge possibility, doesn't it? That the origin, the evolution of life might not be some incredibly unique, improbable fluke that only happened here on Earth.
It suggests it might be a more natural, maybe even inevitable consequence given the right conditions and, crucially, enough time. It certainly forces us to reconsider our place,
Yeah.
and the potential for life beyond Earth.
Speaking of our place, that realization that Earth itself is just, well, a little world.
Yeah.
That was a monumental shift in thinking.
Huge. And that pivotal moment happened way back, 3rd century BC in Alexandria, that incredible hub of learning in the ancient world. And this is where Eratosthenes comes in.
Ah, Eratosthenes. A true polymath, wasn't he? Astronomer, historian, geographer, philosopher, poet, mathematician. I mean, his mind seemed to touch on almost everything.
A remarkable figure. Apparently, one contemporary nicknamed him Beta, kind of dismissively, suggesting he was second best at everything. But honestly, looking at his work, he seems like an alpha in so many fields.
And it was his curiosity about a seemingly minor detail that led to something huge, right? He read about how in Syene, this city way down south in ancient Egypt,
Right, near modern Aswan.
vertical sticks cast no shadow at noon on the summer solstice. The sun was directly overhead.
Just a simple observation. Many might have just shrugged it off. But Eratosthenes, with his sharp mind, he compared this to his own location, Alexandria. He knew that at the very same time, vertical sticks did cast a noticeable shadow there.
And there's the aha moment.
Yeah.
And measuring the length of that shadow in Alexandria, knowing the approximate distance between the two cities, which they had a rough idea of.
Yeah, from surveyors and travelers.
He was able to calculate the circumference of the Earth, and with astonishing accuracy for his time, this simple observation led to this massive insight. Earth is a sphere, it's measurable, a fundamental shift in how we saw our world.
It's just such an elegant demonstration, isn't it? Careful observation, logical reasoning, unlocking these profound truths. And this understanding, this journey of realizing our place, naturally leads us to wonder, well, are we alone?
The age-old question.
The search for life beyond Earth, it's really a fundamental extension of that desire to understand who we are, where we fit in.
And Sagan poses these really deep questions. If life is out there, will it be based on the same organic molecules as us? The same fundamental chemistry?
Or could it look completely different? Something stunningly alien, adapted to environments we can barely conceive of. What other possibilities even exist?
These are questions that really push our imagination,
Yeah.
And the very nature of life here on Earth, with that remarkable underlying molecular unity, it gives us a starting point, but maybe also limits our thinking.
Well, that unity is striking. You, me, a giant redwood, a deep-sea anglerfish, even like a slime mold.
Yeah.
At the most basic level, we're all built using the same toolkit.
Nucleic acids for heredity.
Right, DNA or RNA. Proteins as the enzymes doing all the work.
And that universal genetic code. The same instructions work across almost all life.
And the most compelling scientific explanation for why everything is so similar deep down is common descent. All life on Earth shares a single ancestor, tracing back to one origin event billions of years ago. It points to this fundamental interconnectedness.
Which then leads to the origin question. How did those first crucial molecules even arise? Sagan describes those pre-biological chemistry experiments, like the ones at Cornell, simulating early Earth conditions.
Right, mixing those gases thought to be common back then, hydrogen, water vapor, ammonia, methane, and then zapping them with energy, like sparks for lightning or UV light for the early sun.
And what happened?
Well, remarkably, complex organic molecules formed spontaneously. Amino acids, the building blocks of proteins, appeared in the mix. It wasn't life, but it showed that the basic chemical steps towards life might not be so improbable.
Like the universe has this natural tendency to cook up the ingredients.
It certainly hints that forming organic matter is a fairly natural outcome under certain conditions. Conditions we now suspect exist in lots of places out there.
Fascinating. Now, shifting focus a bit. It's interesting how our human perspective shapes how we even see the cosmos. like the constellations.
Oh, absolutely. Sagan points out how cultures everywhere have always projected their own interests, their fears, even just their everyday objects onto those random-seeming star patterns, like 17th century European sailors charting the southern
They
skies.
put up toucans, telescopes, the sterns of their ship.
Exactly. And he playfully imagines what 20th century constellations might have looked like. Maybe a bicycle, a refrigerator, a rock and roll star, or, more darkly, a mushroom cloud.
It really highlights how our cultural lens just shapes everything, even how we map the heavens.
It's a good reminder. Even our connection to the stars is filtered through who we are right now. But of course, there are also those fundamental, predictable cosmic movements that our ancestors observed so keenly.
Right. Not the fleeting falling stars, which we know are meteors, just space dust burning up.
Little bits of rock or ice.
But the actual stars, they have this comforting regularity, rising in the east, setting in the west, different constellations appearing with the seasons.
And ancient civilizations were incredibly good at using these patterns. It was their calendar, their clock. Think of the ceremonial kiva at Chaco Canyon, precisely aligned with the summer solstice sunrise.
Wow.
They were reading the sky like a giant almanac, deeply connected to those cosmic rhythms.
Like they were just attuned. Okay, let's jump forward to a time when that scientific curiosity was really starting to bloom, but still wrestling with superstition, the time of Johannes Kepler.
Kepler's life is fascinating because it really spans that turbulent transition. He started out studying for the clergy, actually. He had this deep belief in a divinely ordered world, one that was meant to be studied, understood through math and observation, the music of the spheres.
But that era was also just steeped in superstition, wasn't it? People
Yeah.
blaming supernatural forces for hardship, for illness.
Absolutely. And Kepler faced this head-on, very personally, when his own elderly mother was accused of witchcraft. A terrifyingly real danger back then.
God, imagine that. One of the greatest scientific minds having to defend his mom from witchcraft charges.
And he approached it like a scientist. He meticulously gathered evidence, trying to find natural explanations for the things she was accused of doing, the supposed curses or illnesses.
Did it work?
Eventually, yes. After a long ordeal, she was released, though exiled. And his determined defense actually contributed to a decree in Württemberg discouraging flimsy witchcraft trials. It's a powerful example of reason battling superstition in his own life.
Wow. And those superstitions weren't just about earthly things, right? Cosmic events freaked people out too.
Oh, definitely. Unexpected things in the sky, comets, meteors, whatever, often triggered panic or at least intense speculation about omens.
Like the Tunguska event in 1908 in Siberia. That must have seemed completely baffling.
Totally bizarre. Eyewitness accounts describe the sky splitting open, intense heat, a huge blast wave flattening forests for miles, tremors like an earthquake. A massive cosmic mystery.
And then Halley's Comet in 1910. That caused quite a stir.
A real mix. Scientific fascination, big public gatherings, but also widespread fear. People thought the comet's tail might be poisonous gas. You had hucksters selling anti-comet pills and gas masks.
Seriously, anti-comet pills.
Oh, yeah. And the newspaper headlines were wild. Things like comet comes and husband reforms or entire human race due for free gaseous bath. It shows how powerfully these celestial visitors grabbed the public imagination.
Even decades later, that funny story Sagan tells about the drunk caller to Yerka's observatory.
Right. Mistaking comet Aaron Roland for something that disappeared when you looked right at it, it just highlights how the cosmos can still be a source of wonder, but also, yeah, a bit of confusion sometimes.
Keeps things interesting. Okay, so turning back to the regular players in our solar system, the planets. There's a reason their orbits are mostly nice and circular, well spaced out.
Sagan calls it a kind of collisional natural selection from the early solar system. Back then, things were chaotic. Planets forming, orbits crossing.
So if you had a weird elliptical orbit that crossed another planet's path,
Boom. Eventually, you'd likely collide or get flung out of the system. The survivors were the ones that settled into these more stable, nearly circular, well-separated paths. They gradually grew over time.
which is different from comets, right? They have those
Yeah.
wild, stretched out orbits.
Exactly. Comets are generally seen as newcomers to the inner solar system, coming in from the distant Oort cloud or Kuiper belt. They haven't gone through that same long-term orbital settling process.
So it's like cosmic bumper cars, and the ones that didn't crash got to stay. Now, speaking of impacts, Sagan mentions the rare chance of actually seeing an impact on the moon from Earth with just your eyes.
It's extremely rare, yeah. You wouldn't expect many historical records of something like that. But There is this intriguing account from Gervais of Canterbury back in 1178.
What did he report?
5 monks, apparently credible witnesses, described seeing the upper horn of the crescent moon suddenly split in two, with fire and sparks flying off it.
Whoa. And does modern science have anything to say about that?
Well, interestingly, this account lines up pretty well location-wise on the moon, with a relatively young-looking crater called Giordano Bruno. It's got this huge, prominent ray system suggesting it's not ancient.
Okay.
And even more intriguingly, those laser retroreflectors left by the Apollo missions, they let us measure the moon's position incredibly accurately. And they detected a slight, persistent wobble, a libration.
Oh, wobble.
Yeah, like a bell that's been rung recently and is still vibrating slightly. Calculations suggest this wobble is consistent with a large impact happening within the last 1,000 years or so, around the time Giordano Bruno might have formed.
So the monks might have actually seen the impact that created that crater?
It's not definitive proof, as Seguin is careful to say, but the alignment of the historical account, the crater's appearance, and the modern wobble data. It's very suggestive. A fascinating connection across centuries.
A centuries-old cosmic whodunit. Okay, let's take a virtual trip next door to Venus, our veiled sister planet.
Venus. Always a challenge because of those thick, permanent clouds. Totally hides the surface. But radar changed the game. Ground-based radar, and especially spacecraft like the Pioneer Venus orbiter.
They could pierce the clouds.
Exactly. They mapped the surface features, and what they found is pretty surprising. A lot of impact craters, actually. Similar density to the ancient highlands on our moon, which suggests Venus has a surprisingly old surface.
But the craters are different, right? They're kind of shallow.
Remarkably shallow, yeah. The thinking is that the surface temperature on Venus is incredibly hot enough to melt lead. Over geological time, even silicate rock behaves a bit like super thick taffy. It flows very slowly, causing the craters to flatten out.
So the ground itself is slowly erasing the impact scars. Wild. What else is down there?
A dramatic landscape. Towering mesas, huge plains, a massive rift valley, lots of volcanoes, even a mountain range as tall as Everest, all hidden under that incredibly thick, scorching hot atmosphere.
And wasn't there a weird story about a diamond on the Pioneer Venus mission?
Yes. Apparently, a 6.2-carat diamond was sent along on one of the probes. There was some initial kerfuffle with U.S. Customs about declaring it for export.
Seriously?
Yeah, but once the spacecraft was on its way to Venus, Customs decided, well, it wasn't really subject to terrestrial trade anymore, and refunded the duty paid. A little amusing footnote to planetary exploration.
That's hilarious. It makes you wonder, though, what if intelligent life evolved on Venus, under those clouds, never seeing the stars? Sagan muses about that, doesn't he?
He does. Imagine Venusian astronomers developing science, maybe finally building something that could break through the clouds and see the universe for the very first time. What a revelation that would be.
It really underscores how much our own view, our relatively clear sky, has shaped our entire understanding of the cosmos. Okay, let's contrast that with Mars, the red planet.
Mars. So much history there in our imagination. Percival Lowell and his canals.
Edgar Rice Burroughs and John Carter on Barsoom.
Right. But the reality revealed by the Viking landers in the 70s was, well, quite different. That first landing, Viking 1 in 76, it was just a pivotal moment.
What was that first picture like?
The very first one was just its own footpad sitting on the surface. Then the panorama opened up, and it wasn't some wildly exotic alien landscape. It looked surprisingly familiar.
Familiar how?
Like arid parts of Earth. Colorado, Arizona, Nevada, maybe. Reddish rocks, sand drifts that looked windblown, distant hills. It felt somehow more accessible than Venus.
Yeah, Venus seemed utterly hostile. Mars felt like a place. Maybe a place we could actually go someday.
Exactly. It felt like somewhere we'd return to. It reignited that sense of possibility for exploration, maybe even eventual settlement.
Now, speaking of exploration and the flourishing of ideas, Sagan draws this really interesting parallel to the Dutch Republic in the 17th century.
Yeah, that's a fascinating connection he makes between their powerhouse seafaring and exploration across the globe and the vibrant intellectual and cultural boom happening back home.
How do they connect?
Well, the advances in shipbuilding drove technology. Inventions were really valued. There was this societal commitment to freely pursuing knowledge. Holland became a major center for publishing. They'd print things other countries ban.
Encountering all those new lands and cultures?
It challenged the old ways of thinking, showed that long-held ideas about geography, about societies, could just be flat out wrong. Plus, their governance structure, being more elevated by the people, less monarchical.
Fostered openness.
Exactly. Openness, tolerance, encouraging intellectual life. It contributed to this confident, forward-looking vibe. Really shows how society's structure can boost or hinder the growth of knowledge.
Absolutely. And that spirit, questioning old ideas, thinking about other worlds, it wasn't just the Dutch, Galileo, Giordano Bruno. They'd already floated the idea of other planets around other stars.
Right. And Christian Huygens, building on that, he reasoned by analogy. If the stars are other suns, well, it's highly probable they have their own planets, too.
And he didn't think they'd be empty, did he?
No, he argued it would be unreasonable to think all those worlds were just vast, empty deserts. He felt they must harbor creatures, beings that would, quote, more plainly bespeak their divine architect.
Did he speculate on what they'd be like?
He did. And, inevitably, some of his ideas reflected his time, assuming they'd have hands and feet, walk upright. But he was also open to different forms. He basically argued God wouldn't create all that space for nothing, just for us to look at. It's interesting seeing that pre-Darwinian mind grappling with cosmic life.
It really is.
Yeah.
Shows how even brilliant thinkers are products of their time. Okay, let's journey now to a very different kind of world. Intense, volcanic, Io, one of Jupiter's moons.
Io is just extraordinary, a volcanic powerhouse, way more active than Earth right now. Voyager caught these incredible images of massive plumes erupting hundreds of kilometers high, just spectacular geological activity.
And what drives all that? It's Jupiter, right? The gravity.
Primarily, yes. The immense tidal forces from Jupiter and also tugs from the other big moons like Europa and Ganymede. They constantly flex and stretch Io's interior, generates tremendous frictional heat. It's like a perpetual cosmic squeezing that keeps it molten inside.
Wow. So it's constantly churning. Does it have an atmosphere?
A very thin one, mostly sulfur dioxide, which comes straight from the volcanoes. Sagan speculates this thin atmosphere might offer a tiny bit of protection from Jupiter's intense radiation belts during the day. But at night, it gets so cold that atmosphere probably freezes out as frost. Any life would likely need to be underground.
Harsh place, but captivating. And those volcanoes affect the whole Jupiter system, don't they?
They really do. Io is the main source of that huge donut-shaped ring, the torus, of charged particles circling Jupiter along Io's orbit. And those particles, spiraling in towards Jupiter, are thought to be what gives Jupiter's innermost moon, Amalthea, its reddish color. It's all connected.
Amazing. These invisible interactions shaping moons millions of miles away. Now, Sagan briefly mentions humans in the Jovian system. Landing on Jupiter itself is out, obviously.
Gas giant, no solid surface, crushing pressure.
Yeah.
Yeah, no landing.
But he floats the idea of balloon cities.
Yeah. Floating high in Jupiter's atmosphere. A very futuristic, maybe slightly whimsical idea for the far, far future. But for explorers on Io or Europa, Jupiter itself would just dominate the sky. Huge, unmoving because of tidal locking. A constant, awe-inspiring presence.
And Jupiter itself is fascinating, the failed star.
Right. The biggest planet got so massive, it was almost enough to ignite fusion in its core, but just fell short. It actually radiates more heat than it gets from the sun, mostly infrared. A giant warm world just below stardom.
Shows that fine line in the cosmos. Okay, let's shift perspective dramatically again. Back to Earth, way back, to our hunter-gatherer ancestors.
It's easy to forget our roots, isn't it? Sagan paints this picture of early humans living so close to nature, totally dependent on it. Survival was the daily focus. Food, shelter, avoiding danger.
Their knowledge wasn't abstract science, it was practical observation.
Exactly. Tracking animals, knowing which plants were edible or medicinal, making tools from stone, wood, bone. A really intimate, essential relationship with their environment, reading the signs of nature just to stay alive.
A connection most of us have totally lost. And even things we take for granted, like air, that had to be discovered, right?
Empedocles' thought experiment is a good example of that early scientific thinking. He noticed if you put a container, like a cup, upside down into water, the water wouldn't rush in if you blocked the opening.
Because something was already in there.
Exactly. He deduced there must be this invisible substance air that could push back, exert pressure, a huge step realizing the world contains things we can't directly see.
And that spirit continued, like Huygens again, trying to measure the distance to the stars.
His method for Sirius was so clever, he basically compared its brightness to the sun's light shining through a tiny pinhole. He reasoned Sirius looked way dimmer, so it must be vastly farther away.
How close did he get?
His estimate was about half a light year. Not quite right, Sirius is about 8.8 light years away, but considering his tools. Amazing reasoning. If he had known how intrinsically bright Sirius actually is, his calculation would have been incredibly close. Just shows human ingenuity tackling the immense unknown.
It really does. And it reminds us that even those star patterns, the constellations, they aren't fixed forever. They change.
Right. Not only do they look different depending on where you are in the galaxy, but the stars themselves are moving independently. So over millions of years, the shapes distort. Stars are born, stars die.
Like the Big Dipper.
Sagan points out, a million years ago, it looked more like a spear shape. The stars have drifted since then. So in theory, if you were magically transported way back in time, the constellation patterns could maybe tell you roughly when you were.
A cosmic clock based on stellar drift.
Cool. Okay, let's talk about a really fundamental shift, rejecting privileged perspectives. Einstein and relativity. Yeah, the history of science is partly shedding these biases, right? Thinking our tribe, our nation, our planet is somehow special, central, culturally, politically, and scientifically, the Earth-centered view held for so long.
Aristarchus, Copernicus challenged that geocentric idea centuries ago.
But Einstein took it much further in physics. He rebelled against the whole idea of a privileged frame of reference. No special place, no special observer, no absolute motion.
So the core idea of relativity is universal laws.
Basically, yeah. The laws of nature are the same for everyone, everywhere, no matter how they're moving. It's a profoundly democratic view of the universe at its most fundamental level, levels the cosmic playing field.
It really does. Now, speaking of mind-bending ideas, Sagan touches on the multiverse, alternative histories.
This gets into really speculative territory, the idea of parallel universes, maybe infinite universes, where every possible quantum outcome happens. Each choice, each random event, potentially branches off a whole new timeline.
So if you went back in time, hypothetically, and changed something small,
you might create a whole separate reality, one completely unaware of ours. It's a wild thought experiment. Suggests reality could be vastly more complex, infinitely diverse than our everyday experience hints at. Really challenges our linear view of time.
definitely stretches the brain.
Yeah.
Okay, back to something more grounded. How planets actually form. It's kind of like a cosmic lottery.
That's a good way to put it. The standard model is these huge clouds of gas and dust collapse under gravity. But the starting conditions, how dense the cloud is here versus there, how fast it's spinning initially, those vary a lot.
Leading to different results.
Exactly. Computer simulations show you can get systems like ours, or systems with no planets, or systems with huge hot Jupiters orbiting really close to their star, or multiple stars, just a huge expected diversity across the galaxy, potentially hundreds of billions of planetary systems, each unique.
Imagine the skies on those worlds. Multiple suns, giant rings, huge moons filling the view, nebulae painted across the night. Incredible variety.
It really fuels the imagination, the anticipation for discovery, and thinking about all this, it's crucial to remember the timescales. Cosmic time is just immense. A human lifespan, decades. It's nothing compared to a star's life, billions of years.
Sagan uses that mayfly analogy, right? Living just one day.
From a star's perspective, that's kind of like us, just a fleeting blip. But even in our brief time and on countless other worlds, things are happening, shaping futures. Our current moment here on Earth feels like a really significant turning point in our own story.
A humbling perspective. Now the stuff, everything's made of the elements.
Overwhelmingly, the universe is hydrogen and helium, like 99% of normal matter. All the heavier stuff, the carbon, oxygen, iron that make up planets like Earth and us,
Comes from stars.
forged inside stars through thermonuclear fusion, crushing lighter atoms together under incredible heat and pressure to make heavier ones.
Then how does that stuff get out of the stars?
Mostly through supernovae, the explosive deaths of massive stars. We have records of one seen in our galaxy centuries ago, Tycho's supernova, Kepler's supernova.
But we haven't seen one in our galaxy with telescopes.
Strangely, no. Not a really bright, obvious one. We see them all the time in other galaxies, though there have been energetic events nearby, like that intense X-ray burst from the supernova remnant N49 in the Large Magellanic Cloud.
But that might have been something else.
Yeah, Sagan mentions the alternative idea, maybe a flare from a weird type of neutron star, flaring pulsar. Science often has multiple possibilities to sift through, but the basic picture holds. Supernovae are the main way heavy elements get scattered into space, ready to form new stars, new planets, maybe new life.
So stars create the ingredients for future generations, even as they die.
Yeah.
Powerful stuff. Okay, let's talk about some real cosmic enigmas. quasars.
Quasars, incredibly luminous objects seen at huge distances. They pump out unbelievable amounts of energy, way more than entire galaxies like ours. What powers them has been a huge mystery.
What are the theories?
Sagan lists a few. Supermassive black holes at the center of galaxies, gobbling up enormous amounts of gas and dust. Maybe collisions of millions of stars packed tightly together. Stellar chain reactions, matter-antimatter annihilation, even theoretical white holes. Lots of ideas being explored.
Whatever they are, they're extreme. Represent some serious physics happening out there.
Now back to the big picture. The Big Bang. The evidence is strong, right?
Very strong. Key piece is the redshift of distant galaxies. Like the Doppler effect for light things moving away look redder, shows the universe is expanding.
And the other big piece.
The cosmic microwave background radiation, the CMB, this faint afterglow from the very early universe, just a few 100,000 years after the Big Bang. It fills all of space. Its temperature, its near-perfect uniformity. It matches the Big Bang predictions beautifully. Though, as Sagan notes, even in the CMB, there are tiny, subtle puzzles scientists are still working on.
Amazing that we can detect echoes from the universe's birth. Okay, another conceptual leap. Dimensions beyond our three. Sagan uses that great flatland analogy. Imagine beings living in a purely two-dimensional world, like drawings on paper. A square in flatland has no concept of up or down until something lifts it up into the third dimension. Suddenly, it can see inside closed rooms in flatland, see its fellow flatlanders from a totally new perspective. And if it drops back down, its descriptions of this up dimension are totally incomprehensible to the others.
So the idea is maybe our three spatial dimensions are embedded in a higher dimensional space we can't perceive.
Exactly. Maybe our 3D space is curved or folded through a fourth spatial dimension. That could potentially explain things that seem impossible in 3D, like traveling in a straight line and ending up back where you started without hitting a barrier. It really messes with our intuition.
Definitely. Okay, let's think about information. The sheer scale of knowledge.
Sagan introduces the bit, the basic unit, yes, no. A light switch is 1 bit. A letter of the alphabet, maybe 5 bits. A whole book, millions of bits, all the libraries on Earth, maybe 10 to the power of 16 or 17 bits. A huge number.
But then he asks, what about civilizations on planets orbiting stars billions of years older than ours?
Right. What kind of knowledge could they have accumulated over that much time? Maybe not just more information, but fundamentally different kinds. He speculates maybe 10, 120 bits, 10, 30, numbers that are just staggering, hard to wrap your head around.
A humbling thought about potential cosmic wisdom. Now, let's imagine one possible alien world, a planet covered in water.
A rare ocean planet. And Sagan focuses on the potential dominant intelligences there, the great whales, like the blue whale on Earth, the largest animal we know of.
And they have traits linked to intelligence, right?
Yeah, mammalian traits. They evolved from land mammals back into the ocean maybe 70 million years ago. They have strong maternal care, long childhoods, they seem playful, things important for intelligence. And in the murky ocean, sight and smell aren't as useful, so they developed incredibly sophisticated sound communication.
Complex songs, clicks,
Yeah.
their own acoustic world.
A powerful reminder that intelligence doesn't have to look like us. It can take incredibly diverse forms shaped by its environment. Now, bringing it back to us, Sagan talks about the triune brain concept.
The idea that our brain evolved in layers.
Kind of, popularized by Paul MacLean. There's the oldest part, the reptilian complex, basic survival instincts, ritual, aggression. Then the limbic system, emotions, moods, parental care, evolved with early mammals.
And the top layer.
The cerebral cortex, especially the neocortex, hugely developed in primates, massively so in humans. That's where conscious thought happens, abstract reasoning, language, math, art, everything we associate with human intelligence and civilization. It's what lets us do these cosmic voyages of the mind.
But even fundamental things about us.
Yeah.
They aren't necessarily inevitable, are they? Like having 5 fingers.
Exactly. Sagan points out that's just an evolutionary accident. We trace it back to a particular type of Devonian fish that happened to have 5 bony supports in its fins. If our ancestor had 6, we'd have 6 fingers and think that was normal.
And our base 10 math system.
Just a consequence of having 10 fingers. It's humbling. So much about us, our genes, our chemistry, our form, even how we think, is partly down to minor accidents in our incredibly long evolutionary history.
He even gives that example. If a specific dragonfly had drowned differently millions of years ago.
Yeah, maybe some other lineage would have become dominant. Maybe intelligent feathered creatures living in rookeries. It just highlights how complex evolution is, how much is chance, and how little we truly understand all the cause and effect chains.
And speaking of major turning points, the dinosaurs. Their extinction was huge for us mammals.
Absolutely pivotal. 65 million years ago, our ancestors were tiny, shrew-like things living in the shadows of these incredible dominant dinosaurs who had ruled for 150 million years.
And some dinosaurs were getting pretty advanced. Big brains, grasping hands.
Yeah, some paleontologists speculate certain dinosaur lines, like the troodontids, might have been on a path towards higher intelligence if they hadn't been wiped out. Imagine sharing the planet with, or being ruled by, intelligent reptiles.
It's startling. So that asteroid impact, or whatever combination of catastrophes happened,
It wasn't just the dinosaurs, it was a mass extinction. But the small mammals survived, the ecological niches opened up, and that paved the way for mammalian diversification, primates, and eventually us. Shows how cosmic events can just completely reroute evolution on a planet.
fragility and chance again. Okay, let's shift to actively looking for others. SETI, the search for extraterrestrial intelligence.
Sagan uses that beautiful analogy. SETI is like searching for an interstellar Rosetta Stone, trying to decipher messages hidden in space, not buried in time like Egyptian hieroglyphs.
He compares it to Champollion deciphering hieroglyphs, using the actual Rosetta Stone, right? Where the names of pharaohs and cartouches were the key.
Exactly. That unlocked a dead language. So the challenge for SETI is, how do you understand a message from a truly alien intelligence, from a different biology, different history? What's the common ground?
And Sagan proposes science and math.
Yeah, the interstellar Rosetta Stone could be the universal laws of nature. Physics and chemistry seem to work the same way everywhere. The same elements exist, quantum mechanics holds, gravity follows the same rules, whether it's an apple falling or galaxies orbiting.
So a message meant for an emerging civilization should be based on those universal principles, to be decipherable.
Ideally, yes. That seems the logical starting point. Now, if such civilizations exist, why haven't we found them?
Well, Sagan points out we probably wouldn't expect them in our own solar system, right? Either they'd be way behind us or way ahead.
And if they were way ahead, maybe they'd have made their presence known somehow. The vast distances between stars mean we need interstellar communication methods, and this leads to the idea of filters, hurdles in the development of a detectable civilization.
What kind of hurdles?
Things like, how common are planets anyway? How hard is it for life to start in the first place? How often does complex life evolve? How often does intelligence arise from complex life? How often does intelligence develop technology capable of interstellar communication?
And maybe the biggest one. How long do such civilizations last?
Right, that's the potential for self-destruction through war, environmental collapse, whatever. This brings us to the thinking behind the Drake equation, even if he doesn't write it out here. It tries to estimate n, the number of communicative civilizations in our galaxy right now.
And it depends on all those factors. Star formation rates, planets per star, Earth-like planets, life arising, intelligence evolving, technology developing.
And crucially, L, the average lifetime of a technological civilization. And that's the killer variable. We have some handle on the astronomical factors, maybe some rough ideas about the biological ones, but L, that depends on sociology, politics, economics, psychology. Essentially, can a species be smart enough to develop powerful technology, but also wise enough not to destroy itself with it?
So the number of civilizations out there can be huge if they tend to survive long term.
Millions, potentially, if even a reasonable fraction can get through that technological adolescence phase without self-destructing. But if L is typically short, then N could be very small. Maybe just one right now. Us.
So the biggest uncertainty boils down to, well, us. Our choices.
In a way, yes. It suggests the main bottleneck might not be biology, but sociology and long-term survival. Now let's think about timing.
Even if there's a civilization, say, 200 light years away.
If they arose a million years before us, their signals or probes would only just be reaching us now. And think what a million years of technological development means.
Unimaginable.
They might be as far beyond us as we are beyond, say, chimpanzees. Would we even recognize their presence? Would their technology operate on principles we don't even grasp yet? Would they even care about communicating with newcomers like us?
And Sagan makes that point about population growth, doesn't he? For interstellar travel.
Yeah, any civilization seriously going interstellar would likely have to achieve near zero population growth first. Otherwise, they'd just strip their homeworld bare before they got very far.
And even if they expand slowly,
It would take a vast amount of time to colonize even a fraction of the galaxy. Our solar system might just be in a quiet, undiscovered patch for a long, long time.
So the great silence, the fact we haven't been obviously visited or contacted, it could be due to vast distances, or maybe advanced civilizations just have different priorities. Maybe they achieve virtual immortality or explore inner space or something else entirely.
Exactly. There are many possibilities beyond just we're alone. It highlights how limited our perspective is, projecting our current drives onto hypothetical beings millions of years ahead of us. Okay, let's step back again. The cosmic perspective and what it means for us.
Sagan quotes H.G. Wells about how recently we even discovered the cosmos, really. For most of history, we thought Earth was everything. Only lately have we realized we're on this tiny speck in this immense universe.
But that realization resonates, doesn't it? We are made of star stuff, literally. Exploring the cosmos is exploring our own origins, our deepest connections. It's a voyage of self-discovery.
And he acknowledges our flaws, our dangerous evolutionary baggage, aggression, tribalism.
But also our capacity for compassion, intelligence, love. The big question is, which side wins out?
And the cosmic perspective helps, seeing Earth from afar.
He argues it can. Seeing that beautiful, fragile blue marble against the black, it can transcend national borders, petty chauvinisms, underscore our shared humanity on this one world.
And he emphasizes our position right now. Alive, aware, powerful. The future of our civilization is literally in our hands. And asks those powerful questions. If we do not speak for Earth, who will? If we are not committed to our own survival, who will be?
It's a direct call to responsibility, isn't it? That comes with understanding our place. And maybe the biggest, most immediate threat to that survival, the one Sagan tackles head-on, is nuclear war.
He frames our current great venture as twofold, breaking free from our primitive brain patterns and venturing outwards, physically and intellectually. But both are overshadowed by our obsession with war, with mutual mistrust.
And he lays out the reality of nuclear weapons with chilling clarity, how relatively easy they are to make now, the unbelievable destructive power in one bomb dwarfing all of WWII, the sheer number of warheads aimed all over the planet, nowhere is truly safe.
He recounts the effects: Hiroshima's airburst, the fallout from Bikini's groundburst, radioactive ash, strontium in bones, iodine in thyroids, the long-term horrors for the people of Rongelap.
And the potential for nuclear winter, blocking out the sun, collapsing agriculture, plus the long-term genetic damage for any survivors. It's grim, but necessary to confront.
He even mentions L.F. Richardson's work on the mathematics of war.
Yeah, modeling conflict statistically, leading to the chilling concept of doomsday, the potential destruction of humanity in a major war, the balance of terror. Mutually assured destruction. It's so precarious. Relies on perfect rationality, no mistakes, no escalation.
Which seems unlikely long-term.
Richardson's analysis of historical war data suggested a waiting time for wars of different sizes. Sagan raises the terrifying possibility that, with modern weapons being so much more lethal, but our motivations for war perhaps unchanged, that waiting time for a truly global catastrophe might be much shorter than we think.
It's an urgent plea, isn't it? To educate ourselves, our governments, to challenge the old ways of thinking. Like Einstein asked, what is the alternative?
There really is no sane alternative to finding a different path, which leads to his slightly surprising point about nurturing.
Right, Prescott's research. Linking physical affection for infants and societal tolerance with lower levels of violence later.
Yeah, suggesting that societies that are more physically affectionate with babies and more tolerant about, say, premarital sex tend to be less physically violent overall. Prescott argued that in the nuclear age, maybe child abuse and severe sexual repression could be seen as crimes against humanity because they might foster the very aggression that could lead to global catastrophe.
That's provocative. Needs more research for sure.
Definitely. But Sagan offers a simple personal contribution, just tenderly hugging infants, a reminder that small acts of connection and compassion matter, maybe more than we realize.
And for his final thoughts, he looks back to Alexandria.
Yeah. The Great Library of Alexandria, that symbol of a previous golden age of science and learning, a center for research, collecting knowledge from all over the known world for centuries, a promise of what a scientific civilization could be.
He talks about the Ptolemies' dedication, how they even forfeited a huge deposit to keep the original Greek tragedies from Athens, sending back copies instead. They valued knowledge that much.
Incredible discoveries happened there. Eratosthenes measuring the Earth, Euclid's geometry, Herophilus studying human anatomy, a truly vibrant intellectual hub.
But it was eventually destroyed. So much knowledge lost.
A tragic loss. And Sagan uses it as a final call. Our task now is to find those lost opportunities, to rekindle that spirit of exploration and discovery, to learn from history both its triumphs and its failures, so we can navigate our own challenging times.
So pulling it all together, this deep dive through cosmos has taken us across this huge landscape, the scale, the dynamism of the universe, the possibility of life elsewhere, the evolutionary forces here on Earth, and this critical point we're at with all our power.
And the constant reminder that our understanding is always evolving. It's not finished. New discoveries keep reshaping how we see everything, opening up deeper mysteries.
So maybe the final thought for everyone listening is this. Given how fragile, maybe even accidental, our existence seems against this vast cosmic backdrop, what is our ultimate responsibility? To ourselves, yes, but maybe also to the potential for life in whatever form beyond Earth. Something to keep pondering.